So what we're going to try and demonstrate today are the principles behind the operation of the interferometer. So the interferometer is actually a misnomer. The interferometer, what Hewlett-Packard call an interferometer, is actually a polarizing beam splitter, and people think of an interferometer as some kind of device that uses somehow or other the interference of light waves to do something. And if you think about the word interferometer, basically it's just using interference in a way that allows you to measure something. So in fact the whole system, the laser head, the measurement devices, everything is all part of interferometer. So the principles behind it are the interference of light waves. So we're going to simulate a couple of waves. So what we've got here on the bottom wave here is a 50 cycle wave that's coming out of a plug pack. So this is just an AC signal at 50 Hertz. So it's 50 times a second. We're getting an oscillation of about 11 volts. So that's going into channel 1. And if we trigger off channel 1 here, we can see we can move that around at different voltage levels, etc. It's not quite a perfect sine wave, and the reason for that is it's just a cheap crap plug pack, and it's picking up distortion from the fluorescent lighting and all sorts of other things, so it's not quite right. On the other channel though, channel 2, what we've got here is an audio generator generating a pure sine wave. Now this is used for audio testing of amplifiers and things, so this has to be a really nice clean signal, and there's lots of trick circuitry in that makes sure that that's a nice clean signal. Now the interesting thing happens when we add these two together. If we look at either signal, you can see they are proper high frequency, or 50 cycles per second. It's pretty fast. You can't count at 50 cycles per second. Okay, if we look at channel A and channel B, we've got those two there. So we can actually get those onto the screen at the same time. Just press the right button on the scope. You'll believe me, won't you? You can actually see those together. We can turn up the intensity a little bit and you can see those. Now what we're triggering off channel 1, which means that one will stay still. And the second channel is where I've got the variance one. So you can see that if I get them so they line up, there's where the peaks and troughs coincide. Now if we add those together, when it's in that state, they'll coincide and you'll get a wave that's, well, you'll actually get an output that's double the amplitude of 1. If you get them so they line up peaks to valleys, they'll actually cancel each other out. So what we'll do is we'll just display them both at the same time, and we'll trigger off the sum of them. So what we're seeing now is the balance of the two. The actual sum of A plus B. So now it's a little bit intense. I'll just turn that down a little bit so it's a bit clearer. We'll turn the scale up so you can see it a little better. So you can see what it's doing now. This is called the beat frequency, and that's pretty close to maybe 1 cycle a second. So 1, 2, 3, 4, maybe a little less than once a second, but that's being produced from two waves that are actually at 50 cycles. And you see that the little distortion wave comes through there, that little bit of distortion that's on that AC signal wave that's coming off the plug pack. Watch what happens when I change the frequency on one of them, just ever so slightly. You can almost get them to cancel out perfectly. Get it just... Now if that other one was a pure sine wave, you could get that to be a perfectly straight line. So that's from two 11 volt, or roughly 10 or 11 volt signals being fed into the scope on separate channels and then being added together to show the sum of the two. So we can speed it up, we can slow it down, we can make the wave go in reverse. So that's the principle that the interferometer works on. You have two light waves that are at slightly different frequencies, and the slightly different frequencies, when they're superimposed upon one another, creates something that is called a beat frequency at a much, much lower frequency than either of the primary frequencies. You can see there we've got it down maybe to once every couple of seconds. So that pretty much demonstrates the principle upon which the interferometer works. Now, why that's important is because we're now going to look in the next test. I'm going to be looking for the equivalent of this electrical wave only in light waves, and it uses a photodetector on the two different channels to actually create an electronic waveform that is a direct correlation with the intensity of the light. So I just thought you might want to see that first before we do the next stage of the video. Okay, so I'll pull this apart now and I'll set up the interferometer and show you where that's gotten to.